so today's review day. Anybody have just any kind of general questions or anything before we start looking at the practice test? I don't even know that we'll have any formulas that we need on this test, do we? I don't think we really have any formulas that we're dealing with on this one. So if we run across one, I'll make note of it and make sure to give it to you. Okay. All right. So test Thursday, and then next Tuesday, let me look at that date. Yeah, next Tuesday will be our last class meeting, and it will just be a review for the final exam. So if you're comfortable and you know you're not going to be taking the final exam, no reason to be here then. Okay, you'll be finished after test 3. I'm not certain I'll have the test finished, test 3 finished by then. If you're kind of on the fence, I mean, go ahead and come if you can. If you're kind of on the fence and you can't come Tuesday or for some reason, I will record that review as well if you decide later you want to take the final. The final cannot hurt your grade. Right? It can only help your grade, so, or do nothing. Right? It either helps or does nothing. So, okay. All right. So, let's see. Number 1, we got a couple of polynomials. It wants us to describe the end behavior. Okay, so that's what the extreme ends of the graph are doing. So if you remember on these, we really don't care too much about most of the polynomial. All we really care about is we care about the leading term. And on both of these, the leading term is already multiplied out for us. We don't have to, it's not factored, so we don't have to do any multiplication or anything to figure out the leading term. Okay, so on A, we've got a leading term of x cubed. So that has an odd exponent. So we know the ends go in opposite directions. So it's got to be one of these two situations where it goes down to the left, up to the right, or up to the left, down to the right. And then the way we figure that out is if we have a positive leading coefficient, that's our situation. Or if we have a negative leading coefficient, that's our situation. Okay, that's kind of ugly there. Let me see if I can. Okay. So on part A, we have a positive leading coefficient, that's a 1, and an odd exponent. So as our x values are going to the right, our y values are going to be going up, so that's infinity. And then as our x values are going to the left, our y values are going to be going down, so that's negative. On B part, we have an even power, x to the 4th. So with an even exponent, either both ends are going up, or both ends are going down. Okay. And both ends go up if we have a positive coefficient, that's like a smiley face. Right? Or both ends go down if we have a negative leading coefficient, that's like a frowny face. So on this one, since we have a -6 as our coefficient, both ends will be going down. So as our x values go to the right, our y values go down. As our x values go to the left, our y values also go down. So both of those are going toward negative infinity. Okay. All right, we only have those 4 situations. You just need to remember which is which. To me, the evens are easier to remember, and then we've got that smiley face, frowny face thing that helps with the sign. The odd ones, a little bit trickier. You need to remember which one's which. Questions on either one of those? No? Alrighty. Let's see what's next. Number 2, if this thing will load here. Okay. So this one starts off pretty similar. We want the end behavior, and then we'll match it up with one of the graphs. But on this one, to get our leading term, since our polynomial is factored, we need to multiply. Okay. This one's not too bad. You could multiply the whole thing out because we're just distributing x. But remember our shortcut, we can just multiply the term with the biggest exponent in each one of the factors together. So here that would just be x times x squared. And that will give us our leading term. So that would be x to the third. And then that's odd exponent, so the ends go in opposite directions. Positive leading coefficient, so it goes down to the left, up to the right. Okay. So y values go down on the left, go up on the right. And then it tells us to match polynomial with one of the graphs. So no, it's not this one because the end behavior is not correct. That one would have to be an even leading term. And that was not this one because that one would have to be even as well. Right? They're both going the same direction. Let's see. So that one goes down to the left, up on the right. That's a possibility. I'm going to check the other ones. No, it's not this one because it's backward, going up on the left, down on the right. We just have those 4 on this one. Yep. So since we just have those 4, the only one that even has the correct end behavior is that one. If you had more than one thing we could check is we can check where it crosses the x-axis. So all those numbers, -2, 0, and 2, should give us 0 if we plug them in. We can double check that here. Okay. If we plug in 0 for x, we'll have 0 times something, so that's 0. If we plug in 2, we'll have 2 times 2 squared is 4, minus 4 is 0, so that'd be 0. -2 squared would be 4, minus 4 would be 0. So all 3 of those would give us 0 for this polynomial. So that's another way to verify that that's the proper graph. Because sometimes you have more than one with the right end behavior, right? The correct end behavior. Okay. Questions on that one? Okay. The end behavior was really all we had to have on that one, but since we had to kind of remember how to figure out our leading term on that one. Okay. Oh, we did have 2 other graphs, but they both went the wrong way, so they were just on the other page. Okay. Number 3 gives us these 2 polynomials and tells us to divide. So we want to divide P by D. Okay. And this one we can do it either way. We can either do synthetic division or long division. Okay. I'm going to guess most of you would probably rather do synthetic division. So we'll do this one synthetic, and then if you want to do the other one long division, we will. Okay. So with synthetic division, let me get a different color here. We take the opposite of whatever's with the x. So that was x minus 2, so we're going to write down the positive 2. Okay. And then I'm going to write down the coefficients off of the polynomial I'm dividing. Okay. And we also have to look to see if we're missing any powers of x. If we're missing any powers of x, we need to put in a 0 placeholder. Here we've got them all. Our exponents go 2, 1, and 0. 2, 1, and nothing. So we don't need any placeholders, and our coefficients are 2, minus 5, minus 5. Okay. Then when we do our synthetic division, we bring the first number down. And then we do 2 at the bottom times the 2 out front will give us 4. And just combine, right? So minus 5 plus 4 would be minus 1. And then the minus 1 at the bottom times the 2 out front gives us negative 2. Minus 5 minus 2 is negative 7. And that last number is going to be our remainder. This one wants us to write it all together. So the quotient plus the remainder over the divisor. So these numbers that we got are our coefficients for our answer. We just have to remember what power of x to start with. So we started with x squared term. So what power of x is our answer going to start with? Do you remember? Just an x, yeah. So it goes down by 1. Anytime you do synthetic division, your answer is going to go down in degree by 1. So our polynomial here will be 2x minus 1. And then we got to do our remainder. So plus negative 7 over our divisor was x minus 2. Questions on that one? Synthetic division, do it that way. I'm not going to force your hand. I'll let you do either method. It's fine. Okay. Number 4 is the same type of problem. So maybe on this one, let's do long division. Again, you could do it synthetic. So if you want to try it synthetic while I'm doing it long division, that's fine. Should get the same thing. Okay. I got this one set up to do long division. Okay. So I'll look at my x up front, and to get to the 2x cubed on the inside, I see that I need to multiply by 2x squared. Okay. And then I'm going to distribute that to my divisor outside, so 2x squared times x, 2x cubed, 2x squared times 3, 6x squared. Okay. And then I'm going to change my signs. So let's see, that'll give me negative 2x squared. Bring down my next term, minus 2x. And I do the process over again. So to get from x to negative 2x squared, I know I'm going to need to multiply by negative 2x. And distribute again, so negative 2x times x is negative 2x squared. Negative 2x times 3 is negative 6x. Change my signs. So let's see, negative 2x plus 6x is 4x. Bring down my minus 1. So to get from x to 4x, I got to multiply by positive 4. I'll distribute. 4 times x is 4x. 4 times 3 is 12. Changing my signs. Then negative 1 minus 12 is negative 13 is my remainder. So since this one wants us to write it out the long way, or all together, it'll be 2x squared minus 2x plus 4 plus negative 13 over my divisor, which was x plus 3. long as I didn't mess that up. We could check it with synthetic real quick if we wanted to. Since synthetic's so fast. Yep, looks right. Anyway. This one, same idea, it's just a little bit trickier because what's going on, what do we have to remember when we're setting this one up? See anything a little different? Put the 2 out front. Then what about my coefficients? Got 1x cubed, and then what? No x squared, no x, and then I've got a constant of -8. But I got to have some placeholders on this one. Okay. I'll bring down my 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. I have a remainder of 0 on this one. And then what's my quotient going to start with? It's going to be a 1 something, a 1 what? X squared, yeah, so 1x squared plus 2x plus 4. And then no remainder on that one. Questions on that one with the placeholders? Good, okay. All right. So this one, I'm not as concerned with this part for your plotting points. I'm not going to make you do a lot of that, as I am being able to pick out the graph. Okay, what's the general shape of the graph going to be? We could do this though. That's 1 over minus 1 over 36. And you just plug in the calculator on these. So it's just 6 to whatever power. Part I'm more concerned about is picking out which graph would match up. And it's just getting the general shape. So we've got an exponential. What's the general shape of an exponential? Which one? We'll call that 1, 2, 3, 4. Gotta guess you got 25% chance, and there's no penalty for being wrong. What do you think? Our graph, we're looking for the graph of that one. 4. 4 would be it if it was that. Then that would be 4. This one, since our base is bigger than 1, is going to be this one. And so it starts off small and then gets really big. And that's true for any of these where b is bigger than 1. It's going to be that general shape. But if you forget, right, then you could figure out plotting some points, right? Do the little table. figure out what some points should be on the graph, and you can check to kind of see if they look like they should be on there or not. Like 236. Here's 2, so 236 is not on that one, but 236 is on that one. Okay. So you can use that to help you if you need to. Okay. Questions on that one? So this would be 6 to the negative x, or 1/6 to the x. This one would be negative 6 to the x. And this one would be negative 6 to the negative x. You remember those transformations, right? If we do put the minus sign out in front of the whole thing, like that one, it flips it top to bottom. And then if we put a minus sign with the x, it flips left and right. And on this one, it did both, flip left and right, and then flip top and bottom. Okay. And this one's similar. Got 4 graphs and need to match them up. So which one would be just a regular 2 to the x with no minus signs anywhere? Yeah, this one would be. Okay. So the one with no minus signs is going to be just 2 to the x. Then if you think about the transformations, the one I would usually go for next would be if I just put a minus sign out in front of the whole thing. I know that's going to flip top and bottom. So which one's been flipped top to bottom? 2, yeah. This one's 2. Okay. And then I would go down to the last one, because I don't want to mess with the double minus sign yet. I'll go down to the last one, it's 2 to the negative x. So since the minus sign's with the x, that flips left and right. So we're starting here. We flip left and right. Which one's that? 1. Yeah, it's 1. And then the last one's got to be 4. But the 4 has flipped left and right and top and bottom. Okay. That's just doing. You got to know which one to start with, right? That's important. So there's our starting graph, and then you just do the reflections. Questions on that one? Okay. This one's just a calculator problem. It's just like when we were just plotting points on that graph one. So 4 to the 1/2 power, again, it's a calculator problem, but 4 to the 1/2 power, if we're doing it without a calculator, 4 to the 1/2 would be square root of 4, so that's 2. 4 to the square root of 3, I have no idea what that is. Let's see. That's definitely a calculator problem. Don't know if I trust it or not. My calculator's saying that's like 11.036. To the 4 to the negative 2 would be 1/16. So 0.0625. And then 4 to the 0.6. I have no idea what that is. So let's see, 2.297. Something like that. So just punching those in the calculator. So like that's what we'll find out. Okay. Okay. Questions on that one? I don't really know what you would ask. When we're on 9. Okay. We got a couple of equations in logarithm form. We want to change those to exponential form. So on A, the base of our logarithm is 5. So the base in exponential form would be the same thing. So that means 5 would be our big number. And that says 5 to what power? 1. It's the thing on the other side of the equal sign. So 5 to the first power equals the thing inside of the logarithm equals z. Okay. B is easy after you've got that one because you can kind of follow the pattern. But that one says our base on that log is 10. And they've even got it written as base 10 there. They didn't have to for the 10. So we've got 10 to the what power? 5t equals 30. And we're not trying to solve for anything. Okay? It just says rewrite it in exponential form. Yeah, it doesn't matter. Yeah, whichever way you want to do it. I'll take it either way on that one like that. So it's base to this power equals the thing on the inside. That equals that. Question on those? Again, you don't have to come up with a number answer or anything. We're just rewriting, so you end up with an equation. That's fine. Okay. Number 10, we're going the other way. So the base of our exponential, let me zoom in a little on this one. The base on our exponential, the big number is 7. So that means we'll have log base 7 of 20 equals x. So the exponent's always the thing that ends up on the other side by itself. And then on B, we'll have log base what? Log base 5, that's our big number. So log base 5 of W equals that's it. That's it. We don't have to solve for anything or do any kind of calculation. We're just rewriting. Okay. If we can get our next page to load. The next. Number 11. Similar to the one we had before, except this one we've got a logarithm graph. And for some reason it jumped back like 2 pages. 1 second. Computer's acting up a little bit. There we go. Come on. So Again, my strategy would be, like a one like this, would be to think about what just the regular one with no minus signs would look like. So I'm going to start here. It's log base 2 of x. So if you can remember what just a log function looks like without any minus signs in there, and then we can get started on that. Remember which one that would be? Kind of, it's the inverse of the exponential. Okay? So it's number 3, right? We come in and so exponentials start off small and then get really big. And then logarithms come in and they still get big, but they slow way down. They almost look flat. They keep going. So number 3 would be our basic function with no minus signs in there. Okay. So then I would probably try to pick out A next, because it's the one that just has a minus sign out in front of the whole thing. I know that's going to flip the top and the bottom. So if I'm starting with number 3, I flip the top and the bottom. Which one's that going to be? That'll be 1. Yeah, that'll be 1. Okay. So these are just flipped over the x-axis. 1 and 3 are. And then I would probably look at at D down here where I've got the minus sign in there with the x. If I've got a minus sign with the x, that's going to flip left and right. So if I start with this one and I flip it over the y-axis, which one's the 2? It's 2. Nope, sorry. Not 2's D. And then B, we got a minus sign out in front, and we got a minus sign inside with the x. So we're starting with this one. We're flipping top and bottom because of the minus sign out front, and then we're flipping left and right. So we're going to end up with like this shape. So that one is 4. That one's 4. Okay. So exponential is like that. Log looks like that. Okay. Need to remember those. Okay. Just the basic shape. Okay, you don't have to remember many details. Okay. Okay, number 12, using some laws of logarithms. Okay, it says expand. So we're trying to split it up into multiple logarithms. Okay. So one thing we could do, we've got a fraction in there, so we could split the top and the bottom of the fraction up. So we would have log of the top, x to the 6th y, and then log of the bottom, log of z, and what goes in between them, a fraction like that. Plus or minus? Don't remember? Minus. Yeah, minus. Okay. And then, so because we had division, a fraction, so that turns into subtraction. And then our first one there, that log of x to the 6th times y, we can split that part up. That time it's x to the 6th times y. So that'll give us log of x to the 6th plus log of y. Because it was multiplication, and then we still got the minus log of z. Now there's actually one more thing we can do. What else can we do? It's on this one right here. You remember? Got that. We can move that 6 out to the front. That's right. Move that 6 out to the front. So that'd be 6 times log of x plus log of y minus log of z. And so we had those three laws of logarithms. If we've got multiplication inside of the logarithm, this, split it into 2 logs with a plus sign. If we have division or a fraction inside of a logarithm, we can split it up into 2 logs with a minus sign. And then if we have an exponent inside the logarithm, we can move it up front. And I think B part on this one is exactly the reverse of the other one. Right? So I don't know why they did that, but we can take the 6 and move it up. Get log of x to the 6th. Then we combine the first two. So let's see where I want to write this. And a plus, so it turns into multiplication. And then we've got minus log of z, so log of or the z goes on the bottom. All right, you just end up what we had on the other one. All right, it's kind of a little bit hard to see. So B part was basically just working backward from A part. What we got on A part. Here's another one. This one says combine. Okay. So what can we do first on this one? Is it big enough? What I see is we got this 8 out here, so we can move it inside the log. And now this one's almost like the last one. We've got a plus sign here, so we can combine these two, and it'll be multiplication inside, because it was plus. So this will be log of x to the 8th times y minus log of z. And then now we've got subtraction. That means we can combine these, and this will be the top divided by this, right, like a fraction. So we have log of x to the 8y over questions on those? Is that the assignment that's not due till tonight? It is, isn't it? Okay. This one says use the laws of logarithms to expand the expression. Okay. This one we've got 4 times x times y, so it's all multiplication. So you can either do them one at a time as you expand, or with all multiplication, you don't have to worry too much about what order you do it in. Okay, so We can go ahead and split it into 3 if we want to. These are all log base 3s, so we have log base 3 of 4 plus log base 3 of x plus log base 3 of y. And you could do them you could split off each term one at a time if you wanted to. Like you could have log base 3 of 4x plus log base 3 of y, and then split the 4 and the x up. Written on that one? Quiet. You're so quiet. Last one, looks like. It says combine the expression. Just go another direction. So if you've got a number out front, moving that inside the logarithm should be our first step. So this would be log base 4 of 8. I'm not doing anything to that first one. Plus log base 4 of 5 squared. You can just leave it 5 squared. That's okay. Well, I guess we can multiply it out, so it'll make the end product nicer. So if we multiply that out, log base 4 of 25. And then if we combine these two, it's plus, so we would multiply. That would be log base 4 of 8 times 25. What's 8 times 25 going to be? 200. Yeah. You got 8 quarters, it's $2. So 200. Yeah. Do I want you to do it like that, or what was the other option? Yeah, if I give, yeah, I'm okay either way. Yeah. Yeah, if you get here and you give me that it's log base 4 of 8 times 5 squared, I'm happy with that too. So. Yeah. Either one's okay there. Any other questions? Okay. That's it then. I'll see you Thursday. Okay.